why don't you take a few minutes to work on this yourself? Let's see, what's a good goal in say 4 or 5 minutes? So obviously you want to get the first and second derivative, right? Yeah, exactly. It'd be like 1040. So let's make sure you get the first derivative. Let's make sure you get the second derivative. And fully simplified, right? Factored and simplified. So that's your first goal, factored and simplified. And then, let's see, information from F. We need to get vertical asymptotes and horizontal asymptotes. So try to do as much of that stuff first. So I think that's good for like 5 minutes. Let's do 5 minutes and try to get this. This is your first goal. Um, maybe a little more than 5 minutes. If you do want to ask questions in chat or over voice, that's perfectly fine. And I will charge the Apple Pencil. There you go. So was that a good estimate of what you can get done? Jacqueline, what did you get done?
I think I got the asymptotes and the factor things.
So you're saying you got everything?
I think so.
Okay.
I don't know if
Thomas,
it's right, but
you don't know if it's right, but you got something done. Thomas, what did you get? Anyone else can chat can also answer. I'm just curious to see where people got up to.
I just got the first and second derivative and the vertical asymptotes. I was working
Okay.
on the horizontal.
All right. Is that where a lot of other people are? Hirsch, Rachel, anyone else in chat who is here? You know, all the 50 people who are also taking this class that aren't on camera? Yes? Yes. Okay. All right. So our first derivatives. Okay. So my first derivative, fully factored. So you do product rule, right? There's a common factor of e to the negative x. And we get here x. Whoops. We get x times 2 minus x times e to the negative x. That's the fully factored first derivative. Okay. So just compare that with what you had. If you have any questions, you can ask. Okay, and then for f double prime of x, use product rule again. Obviously, I wouldn't use triple product rule. I'd write this as 2x minus x squared e to the negative x, and then I would use product rule on that, and then fully simplify. And let's see what we get. We get x squared minus 4x plus 2 e to the negative x. Now this is not factorable over the rational numbers, so I'm instead just going to complete the square. That'll make some things easier. So this is x minus 2 squared minus 2 e to the negative x. Do we all remember how to complete the square? You all remember that from pre-calculus and algebra? And if you don't want to complete the square, that's fine. You can just keep it in the expanded form, right? Whatever. But the important thing to realize is that this is not factorable over the real numbers, so we will have to use quadratic formula at some point to solve f double prime equals 0. So any questions about either of those two derivatives? Okay. All right. So yeah, even this is like derivatives should be something that comes natural to you guys by now, hopefully. All right, so now let's talk about asymptotes. So it looks like from the chat, most people said they had gotten the vertical asymptotes, but they were maybe working on the horizontal asymptotes. So all y'all who talked in chat, what are the vertical asymptotes? X equals 0, x equals 2. None. 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 No vertical asymptotes. So it looks like the answer is none. Okay, so if you got x equals 0, x equals 2, your mistake was setting f prime equal to 0. X equals 0 and x equals 2 are the critical points of this function. They're not the vertical asymptotes, right? And Anjuman has a good point, right? Anjuman said the function's continuous, right? So this function is continuous, so there are no vertical asymptotes. All right, we have a polynomial x squared. We know that that's continuous, and e to the negative x, we know that's continuous. I mean, when you multiply two continuous functions, you get another continuous function. So there are no vertical asymptotes. Okay, now let's do horizontal asymptotes. So this is where it looks like some people maybe got up to, maybe started. Does anyone have an answer for all the horizontal asymptotes? I think Jacqueline said she had one. Does anyone else have an answer? Jessica, y equals 0. Anjuman, y equals 0. Are there any other vertical asymptotes? Horizontal asymptotes? No? Okay, yeah, so that's going to be the only horizontal asymptotes. Let's actually go through it. So who wants to actually remind us, how do we actually find the horizontal asymptotes, rather? Right, what is our general strategy here? Infinite limits. Well, no, the limit's at infinity. Infinite limits are limits that are themselves infinity or negative infinity. But I mean, I know what you mean. You mean the limits at infinity. So we have to do, there are two things we have to do here. We have to do the limit as x goes to negative infinity of my function. And what is the limit as x goes to positive infinity of my function? Okay. So now let's actually talk about how to do these limits. All right. So this is something everyone should know how to do, right? Find just, how do you start with horizontal asymptotes? And now we look at this particular limit. How do we do the first particular limit, x going to negative infinity? When you analyze this limit, especially for those who didn't really get up to this, take a few seconds to maybe analyze each term. And how does that actually tell you how to proceed? What are we thinking here? If it's a quotient, why do I need it? Why do I need it to be a quotient, Hirsch?
Okay, I think it's just easier to speak on because that's an indeterminate. I mean, that's an indeterminate form, and that's how L'Hopital's rules need it.
Okay, and Yana says it's because it's 0 times infinity. Okay, so what you're saying is correct, right? If it were 0 times infinity, I would need it to be in the form of a quotient to use L'Hopital's rule. But is it 0 times infinity? Let's be sure about that. We're looking at the first limit. As x goes to negative infinity, let's analyze each term. What happens to x squared as x goes to negative infinity? We should all know that. That's just plus infinity, right? If you take a negative infinity squared, you get positive infinity, right, Mohammed? What were you looking on your calculator for? What did you find? What information do you want to share with us from your calculator?
I was just looking at the graph.
Looking at the graph, it's kind of a fun graph, right? And what happens to e to the negative x as x goes to negative infinity? Simran, 0. So we actually do have infinity times 0? Wait, never mind. Positive infinity. Yeah, it's actually positive infinity. Exactly. Remember, e to the negative x looks like this. So as you go to negative infinity, it goes to infinity. And as you go to infinity, it goes to 0. Right? So make sure you get the right direction with the e to the x and e to the negative x, right? So this is actually not indeterminate, the first limit, it's just infinity. However, you guys are right that the second limit is indeterminate, right? For the second limit, the x squared goes to infinity and the e to the negative x goes to 0. So in the second limit, I do have infinity times 0. And then everything you guys were saying about L'Hopital's rule is correct. I needed to put it into the form of a quotient to use L'Hopital's rule. And who would like to put it into the form of a quotient for us? Yeah, x squared over e to the x, right? It's not too difficult. And now we just have a straightforward application of L'Hopital's rule. Right? Because we have just to make clear, why can we use L'Hopital's rule? We have infinity over infinity. So using L'Hopital's rule, I get the limit of 2x over e to the x. And then I can use L'Hopital's rule a second time because I get infinity over infinity a second time. And then I get 2 over e to the x. And finally, I just get 0, right? 2 over infinity. I get 0. That is not indeterminate. That's just 0. So y equals 0 is the only horizontal asymptote. And the next thing is going to be information from the first derivative. Are there any questions so far about anything with the calculating the derivatives, calculating these asymptotes, anything at all? Because we are going to move on. Nishika, what are your questions? Sorry, I don't got none. I don't got no questions. All right. Caleb, you got questions? You got ketchup chips today? You got any ketchup chips? You eating ketchup chips?
No,
No ketchup chips.
not today.
Damn. Okay, so let's copy the first derivative so that it's on the screen. So even if you got the wrong first derivative earlier, make sure you have the correct one now. It's fully factored. So information from f prime. Can someone just very, very briefly remind us what are the things we have to get from f prime? Mohammed, do you want to do that? What do you get from f prime? Do you remember?
Critical point.
You can get critical points, and what do you do? What can you do with those critical points?
Check if it's going down or up. So
Down or up? Yeah, we usually call that what? Increasing, decreasing. And what else can we get? Rachel, do you remember what else can we get?
The local mins and max.
Local mins and maxes, right? And let's see. And how are we actually going to find this? Someone else in chat, someone else who is not on camera. What's the main method we use for once you find the critical points? What's the main method for finding the increasing and decreasing? A sign chart. Good. All right. Specifically a sign chart for f prime. All right, so that's kind of a sketch for this. I'm going to give you another few minutes, maybe work on this yourself. Try to get all of this. Try to get the increasing, decreasing, and the local mins and maxes, right? So in other words, finish the sign chart and then write down the answers for these few things. Now, since you already have the derivative, this shouldn't take as long. So maybe let's say 4 minutes. It's probably a good estimate to get most of it. All right, how are we doing? Are we able to get everything? The whole sign chart? Do you need another minute? Did most people get it? How are we doing? Ayana says, yep. Yes. Okay, well, 2 people got it. I have the chart with the signs, all good? Okay. All right, well, no one else is really saying anything, so I will take the word of these 3 students to be representative of everyone. Didn't get to min-max yet, but if you got the sign chart, you can get the min-max in like 2 seconds, right? The sign chart is the big thing. Okay, so let's get our critical points. So as usual, I just want to keep consistent with what I wrote for the other ones. So construct a sign chart for f prime. What are our cut points? Right, x equals 0 and x equals 2. I do want to emphasize here, because I do get this question a lot sometimes. Notice we had a horizontal asymptote at y equals 0. Now, it's a coincidence that x equals 0 is actually a critical point, and y equals 0 is also a horizontal asymptote. If we had gotten, let's say we had gotten a horizontal asymptote of y equals 1. Does that affect our cut points for this chart? Like, let's suppose that. And let's actually also let's also say the vertical asymptote was at x equals 3. So let's suppose that these things were true. How would you modify your cut points, if at all? So yeah, you said we would add them to the sign chart. So are you saying you would add both 1 and 3 as cut points to the sign chart? Is that what you're saying? Okay. Simon, would you add x equals 3 as a cut point? Caleb, would you choose a value between 2 and 3? So you're implying that x equals 3 would be a cut point. Okay, so it looks like a few people are saying x equals 3 would be a cut point. So that is always true. Vertical asymptotes always have to be a cut point, right? Why? It's because that's a place where the derivative is not continuous. So you can have a change in sign across a vertical asymptote. But what about the horizontal asymptote? So only Aya commented on it. Does anyone else want to comment on the horizontal asymptote? I say nothing, it'll just make it shorter. What does that mean? What is this? Is this some stupid meme, Caleb? Simran says no because it's on the y-axis. So Aya said she wants to include it. Simran says no. What do other people say? 2 out of 58 people. Like the graph has a height limit? What? Not y equals 1 because it can go through it? I think no because the graph shifts up. So I haven't really seen the correct answer quite just yet. So I will say this, the answer is no. So you do not put horizontal asymptotes on as a cut point for your sign chart. But the reason I'm getting it's not really correct. Maybe Simran was the closest. I mean, the sign chart, a y value can't be a cut point. You're right, because I'm trying to find. I mean, what is the whole point of a sign chart? You're trying to find the sign of f prime. In other words, you're trying to solve the inequalities f prime of x greater than 0, f prime of x less than 0. And what is the solution to such an inequality? The solution is a set of x values. So clearly the sign chart should not include y values. It's just completely irrelevant, right? So horizontal asymptotes do not go on the sign chart. And I did bring that up only because in this case, the 0 kind of was coincidentally repeated. But I do get that question a lot. Horizontal asymptotes don't go on the sign chart because the solution to these inequalities are sets of x values, not y values. Okay, so we just have 0 and 2. So this is sine of f prime, shape of f. Let's write down our test points. So easy test points, right? -1, 1, 3. Okay. And then we do our scratch work on the side. Here's my derivative. I want f prime of -1, f prime of 1, and f prime of 3. So I look at each factor separately. So negative, positive, positive. Then it's 2 minus x. So positive, positive, negative. And then the e to the negative x. Remember, e to the negative x is always easy, right, Hirsch? Why is an e to the negative x easy for a sign chart?
Um,
Why is
guys-
this term easy?
because you guys just like plug in the number.
You plug in the number, but you always get the same thing, right? Justin, what do you always get for e to the yeet, as someone wrote in the
Positive number.
chat? You always get a positive number, right? Yeah. So you get positive, positive, positive. So we just get here negative, positive, negative. Okay. I think Caleb said that in the chat, didn't you? E to the yeet is always positive. Okay, so negative, positive, negative. Can someone remind us what this means, just as a quick, like what should I write up top here in terms of the shape of f? Decreasing, increasing, decreasing, right? Good. Decreasing, increasing, decreasing. Good. Now we can get everything. So f is decreasing where f is increasing. F has a local min at somewhere, and f has a local max at somewhere. Okay, so let's try to get these properly formatted. So what's the decreasing? What is the proper formatting for the decreasing answer? And we did talk about some of the subtleties of how to format this answer right on Friday, if you recall. Looks like Mohammed's typing something. Shouldn't f of -1? Okay, so let me first address this question. Should f prime of -1 be positive? Because -1 squared is 1. Well, Sasha, it looks like you're substituting the numbers into the wrong function. It looks like you substituted -1 into f, not f prime. Okay, so now let's look at all the other answers. So Mohammed, so Mohammed used -1. So that's, make sure you don't do that, right? The -1 was a test point, right? The cut points were 0 and 2. Once you're done with getting these signs, kind of block those test points out of your minds, right? All that really matters are the 0 and 2 at this point. Okay. And it looks like, so it might, looks like there's still a little bit confused about when to include the endpoints. So no one used a union symbol, which was good, right? So we know it has to be separate intervals. But we actually, when do we include the endpoints? Because some people included 0 and 2, some people did not include 0 and 2. If there's no vertical asymptote, when it's continuous. So Caleb, you're right, except the better answer is to say when the original function is continuous. And this original function is continuous everywhere. So -infinity to 0, and then also 2 to infinity, including the endpoints. All right. And then similarly, the increasing interval would obviously be the middle interval from 0 to 2, but including the endpoints. Okay, and now let's get local min and local max. So right in chat, min, where's the min, where's the max? You can put both if you want. Someone says 0 min, 2 max. Right, exactly. And I think I mentioned this. I like to kind of draw the function. Right, it kind of reminds you what the shape is supposed to look like. So the function looks something like that. And you're looking for that sign change, right? The minimum, it goes from negative to positive, the derivative. So we get x equals 0 here and x equals 2 here. Very good. Any questions about any part of this part of the problem? Okay, so now let's do the second derivative. So I'll give you a few minutes for this. I imagine some of you may have been already working on it. So to remind you, the second derivative, you do the same thing, right? You do a sign chart for the second derivative. Okay. So I'll give you a few minutes for this. Try to do this without a calculator. Try to do everything exact without a calculator, but if you do need a calculator, it's fine. But try to do as much as you can without a calculator. I'll give you 4 minutes again. And I'll also, in case you didn't copy the other stuff, I'll put it on the screen. Although if you didn't think to complete the square, you might want to try not to use it. But there it is. Okay. So I'm going to use the complete the square edition. Okay, so we have to construct a sign chart for f double prime. Put this back in presentation mode. So the first thing I'm going to ask is, what are your cut points? So if there were vertical asymptotes, to remind you, we would include the vertical asymptotes, but not the horizontal asymptotes. But we didn't have anything like that. So what were your cut points? Now, to be clear, I know a lot of you maybe would not have completed the square, right? I'm still going to wait for some people to write in chat what the cut points are. So 4 plus or minus square root 8 all over 2. I think that's correct, right? That can actually be simplified to what Jessica wrote, 2 plus or minus root 2. Yeah. Remember, root 8 is 2 root 2. So if you didn't use the complete the square addition of the second derivative, right, I set this equal to 0. The e to the negative x is never 0, so you get x squared minus 4x plus 2. So this is use a quadratic formula. So I get x equals 4 plus or minus square root 16 minus 8 all over 2, right? So I get 4 plus or minus square root 8 is 2 square root 2. And so I get 2 plus or minus square root 2 as my 2 roots. So make sure you actually do simplify that, because it'll be useful to simplify. And obviously, if you had completed the square instead, everything is a lot easier, right? Because if you go here and you complete the square, I say, okay, this is x minus 2 squared minus 2 equals 0. So x minus 2 squared equals 2. Take a square root, x minus 2 equals plus or minus root 2. Then adding the 2 gives you 2 plus or minus root 2. Right, so it's a little bit, you get it right away. But in any event, those are our cut points. Now, does that intimidate you that these are weird, that these are not rational numbers? Does that make you feel not nice about this? If you saw this on an exam, would you panic and not know what to do? Mohammed? No, just convert them into a decimal? Yeah, I mean, you have a calculator. I mean, right? I mean, it's like what someone said. I mean, just use approximations. I mean, obviously, anything you write down on your work, you should use exact numbers. But I mean, as you're working, I mean, you can just use decimal approximations for everything, right, to do the sign charts. So don't get too intimidated. But we're not going to use a calculator. Okay, so my cut points. So obviously 2 minus root 2 is the smaller of the two numbers. So because we don't have rational numbers, I think it's important to actually ask you, what were your cut points? There are 3 numbers. Or not cut points, test points, I'm sorry. Zero, 1, 4. Okay, I mean, 0 is very clearly less than 2 minus root 2, right? Because you should think of 2, that's actually root 4. So you should think of this number as root 4 minus root 2, and this is root 4 plus root 2. Right? So clearly 0 is less than root 4 minus root 2, because root 4 minus root 2, this is a positive number, right? That's positive. As for what is between them, I mean, 1 is between them. That is definitely correct. But I would just go with the average, right? If you have 2 minus something and 2 plus something, what's the number right in the middle? 2, right? So I would just choose 2 as the cut point. And what is a number that's bigger than 2 plus root 2? Well, 4, clearly, because 2 plus root 2 is less than 2 plus 2, which is 4. So I would choose 4 as my cut point. Now, 3 is not a valid cut point for the last integral. 3 would actually be in between the two. So just be careful of that. But of course, if you're working on this in an exam, you can just use a calculator to get your test points. But I think without a calculator, the most natural test points to choose are 0, 2, and 4. Okay, so the e to the negative x is always positive, so Let me just move this. I could make it a little bit smaller. Okay, so the e to the negative x is always positive. I don't really care about that. So the 0 would here give me 4 minus 2, which is positive. The 2 gives me negative 2, that's negative, and the 4 gives me 2 minus 2, which is positive. So I get positive, negative, positive. Nice. Positive, negative, positive. And we all know that that means what? Concave up, concave down, concave up. Oops, local meant to say inflection point. Okay, so can we very quickly format these answers correctly? Where is the function concave down? Let's get the correct formatting on that. So let's see. So Aya says basically the middle interval, and she's including the 2 endpoints. 2 minus root 2, 2 plus root 2. Good. And what about for concave up? So it's going to be the other 2 intervals. And what do we remember? Include the 2 endpoints, and also, what's the other subtlety when we have multiple intervals? Muhammad, we use a union symbol, right? Yeah, no, we just list them separately. And what do we have? Inflection points. Nishika, how do we find inflection points again? What are we looking for? Oh my god.
Where the graph is changing, like direction.
Where what's changing? Not the graph is changing. What feature of the graph
Like
is
at
changing?
a point, the line.
Yeah, but which feature are you looking for a change? So I'm looking for where it goes from increasing to decreasing, right? That changed.
Mhm.
No, not quite. I'm not looking for increasing to decreasing. What am I looking for?
Like concavity.
Concavity, right? Yeah, Justin and Ayana just wrote it, and at the same time you said it. You're looking for the concavity changes. So we do have an x equals 2 minus root 2 and 2 plus root 2. And you knew that answer, Nishika. Okay, so in the interest of time, should I do the... I'll just do the last part, the summary and the graph. Okay, so let's get important points. So first of all, the original function was this thing. Okay, so x, y, type. So 0, then 2 minus root 2 was important. And then we had x equals 2. And then we had 2 plus root 2. Okay. And then we also had y equals 0 was important. That was our horizontal asymptote. So in fact, actually, it turns out I'm not really going to want pretty much any of these values. I'm not going to want to figure out. I am not plugging 2 minus root 2 back into this function. I don't really care. So I'm just going to write this as x equals, x equals, x equals, x equals, and the y equals, and just note what each of these things has to be. So this was a local min. This was an inflection point. This was our local max, right? Yes. Another inflection point. And then y equals 0 was our horizontal asymptote. So again, we'll call it important features, not points. And then here's our summary. The reason why I'm not getting the y values for these points is because, I mean, I guess it all depends on what I'm asking, but I don't really care about the y values. I just want the general shape of the graph. And all I really need to know is the relative value, like, which one is greater than or less than the other one. And I know that from the increasing, decreasing intervals. Okay, so the summary charts, let's 1, 2, 3, 1, 2, 3. So let's do our handy dandy chart here. Okay, so I have to include how many x values? 4 x values. So 0, 2 minus root 2, 2, and 2 plus root 2. Put the increasing up top, put the concavity down below. So looking back at my notes, so the increasing, decreasing changes at 0 and 2, and the concavity changes at the other 2 points. So we have decreasing, increasing, decreasing, and then we have up, down, up. Concavity, right? Not increasing, decreasing. And then I like to color these. So let's do decreasing up. We'll make that green. Are there any other decreasing ups? Yes. Increasing up. And that is the only increasing up. Increasing down. That's the only increasing down. And then decreasing down. Okay. And now we can finally draw the graph. Let's zoom out a little bit. Now, one thing to know is that this function x squared e to the negative x is always positive, right? It's a square times an e to the yeet. So I don't really need to have anything with the negative y-axis. The whole thing is positive. So let's draw our asymptote. Let's draw our points. So 0, 0, that's easy. And then there's going to be a 2 minus root 2. It's going to be a 2 and a 2 plus root 2. So all I have to know is, again, I didn't figure out the y values for these points because I don't really care. I just need to know their relative values. So 2 minus root 2, notice the function is increasing rather from 0 to 2 minus root 2, right? So I'm just going to put a point above that because I know it's increasing. And it's still increasing when I get to x equals 2. And then it starts to decrease after that. So relatively, this is where the 4 points should be, right? I don't really care about their exact values. Let's also put in, let's make sure at 2, we do have a horizontal tangent line there. So I'm just going to put just a little reminder for myself there. And now let's do the sketch, the skeleton. So I have decreasing, increasing, increasing, decreasing, decreasing. So the graph pretty much looks like that. And now let's just add in some nice stuff for the concavity. So I have concave up. Right, and it's concave up from negative infinity to the 2 minus root 2, and then it switches concavity, so now it starts bending the other way. And notice I'm actually also obeying that horizontal tangent line. Let me get this as best possible. Notice that. Yeah. And then it's concave down there, right? So I have the hump, right, the upside down U, and then it starts to bend the other way, and I have to respect that horizontal asymptote. So there's your function. Mohammed, is that what you saw on the calculator? No, it's not. Oh. You gotta look at how you did that calculator. Okay, any questions about any part of this graph? Graphing any part of